Okay, in this video what we're going to do is look at an example of computing elasticity and then answering a couple questions about it, something that's very typical out there. So let's say that we have a linear demand that's given by Q equals 80 minus 2P. And just so you have a visual on that, we know that this is the equation of a line where, if I put price here and quantity here, the y-intercept, or the q-intercept, I should say, is 80, which means the most demand we're going to get out of this is 80, and the highest price we can physically use is 40, because it looks like from the equation, if I try to use a price higher than 40, I'll be paying my customers to take my product away, and that's kind of not the message we want to send. So the domain is between 0 and 40. So as far as elasticity goes, we know elasticity follows the formula E equals negative P over Q times dq dp. So the first thing we have to figure out is what dq dp is, and that's just the derivative of Q with respect to P. So if I take the derivative of that, I just get negative 2. So then elasticity is equal to negative P over, now the idea is to get an expression that's all in one variable. So since Q is already equal to something that has to do with P, we replace all the Q's with its corresponding expression. So this is 80 minus 2P, and then dq dp is negative 2. And what we then get is, since this is really negative 2 over 1, we have 2P over 80 minus 2P. And you could simplify that even further. You notice that all the terms in the fraction have a factor of 2, common factor of 2. So you could also say P over 40 minus P. So that's what I'm going to use. Okay, so then let's look at what's happening at a price of 10. So if the price is 10, that means the elasticity is, by the formula, 10 over 40 minus 10, which looks like 10 over 30, which is 1/3, which, remember from our definitions, is inelastic. So remember that inelastic means that I have room to breathe here, right? I can increase the price without taking away from my revenue. In fact, increasing price is going to increase the revenue. So that's a good thing, okay? What about a price point of 25? What if we want to raise the price to 25? Well, the elasticity equation tells me that if I do that, I'm going to get 25 over 40 minus 25, which is 25 over 15, which is 5/3. Now, we could write that as 1.666666, whatever, but all we need to know is that is greater than 1. So that means this is elastic. So just a little side note here, that means that revenue decreases when P increases. In fact, that result of 5/3 itself means that demand will go down by 0.5% if the price goes up by 1%. So just to get that real life meaning here, demand decreases by 0.5% when P increases by 1%. I remember that's just the definition of elasticity. So, of course, one thing that might be on our minds all the time is, well, how do we maximize the revenue, which means how do I find the unit elasticity? Well, that means we want P over 40 minus P to be equal to 1. So we'll just have a little equation to solve here. We'll multiply both sides by the denominator, so we're going to get P equals 1 times 40 minus P. And, well, okay, so I don't need to write the 1, so I'm just going to rewrite that here for clarity. So I'm going to add a P to both sides. That's 2P equals 40, which means P is equal to 20. So this is the price that maximizes revenue. Okay, and that's where unit elasticity occurs. Another thing we could find, we do have all the pieces to do this. What is the maximum revenue? Well, we know the price is 20, and we also know the quantity because the quantity was given as 80 minus 2P. And that was like 40. So the max revenue is $800. Okay? So there we have it. Elasticity less than 1 means you can raise the price and still garner more revenue. Elastic, meaning elasticity greater than 1, means you should stop raising the price because you're losing revenue. Elasticity equal to 1 is kind of the happy point. That's where your maximum revenue occurs. So if it's possible to do that, that's what we do. And then we can also find the maximum revenue. So hopefully that helps you understand elasticity a little better. We'll do another example in a little bit here, and I thank you for watching.